Namaste. In this video we are going to discuss about Epsilon NFA and converting it to DFA. Okay, so Epsilon NFA is a finite automata which can change its state by consuming an empty string. Okay, let us consider an example like this. Q naught, when we empty string, that means it consumes, and in no string it can move to next step. So this is the Epsilon FA, and multiple number of state converts into, this is called Epsilon NFA. So let us consider an example and convert it into DFA. So okay, let us consider an example. Q naught. Okay, so 0, Q2, empty string. Okay, 1, empty string. Okay, Q1, Q2, and this is 0. So this is an example. Okay, let us consider Q2 is a final. This is an example of Epsilon NFA, and let us convert this Epsilon NFA into DFA. So first of all we have to get the closure. Okay, E closure, SOUR. Okay, closure of Q naught. Okay, so when we get empty string in Q naught, it moves to Q naught. Okay, empty string from Q naught gives to Q1, similar to Q2. Okay, so E closure of similarly Q1. Okay, so Q1 and empty string gives Q2. Similarly of Q2, it gives only Q2. Okay, let us use the same method by which we have used to convert NFA into DFA. So delta Q naught comma Q1 comma Q2, okay, to 0, or this braces can be used. Okay, so we can calculate it. Since it is a ENFA or Epsilon NFA, we have to use its closure. So E closure delta Q naught Q1 Q2 comma 0. So E closure is same which we have used in previous video. Okay, delta Q naught comma 0 union delta Q1 comma 0 union delta Q2 comma 0. Okay, so it is E closure. When 0 is inputted to Q naught, it gives Q naught itself as union. When 0 is inputted to Q1, it does not give anything, that means it doesn't move to any state, that is 5. Q2, it gives Q2 itself. So E closure of Q naught union Q2. So again it is E closure of Q naught union E closure of Q2. So E closure of Q naught is Q naught Q1 Q2. Union E closure of Q2 is Q1 Q2. Yes, so it gives Q naught comma Q1 comma Q2. Okay, and similarly when we use delta q0 comma q1 comma q2, it was for 0, so we have to use it for 1. Yes, and that is E closure of delta q0 comma q1 comma q2 comma 1. So when we use it, we get it as q1 comma q2. Okay, proceed is like this and we get this. Okay, so again, for since this is the new state, yes, so we move. This is also new state it was, so we have moved. Yes, so let us input 0 and 1 to this state, q1 comma q2 comma 0. So similarly, E closure of delta q1 comma q2 comma 0. So E closure is delta q1 comma 0 union delta q2 comma 0. So it gives E closure of q2. Since q1, when 0 is inputted to q1, it gives 5. Yes, and it is q2 itself. We have calculated in previous. Yes, now let's input 1 to q1 q2. Okay, and it gives q1 q2 itself, so we do not get any new state. Yes, so this is termination and we convert, we get. So first state it was q0 q1 q2. Yes, so q0 q1 q2. Since it contains the final state, so this is a final state. Next we have got q1 q2. So next state is q1 q2. Since it contains q2, so it is q2. And next state we have got is q2. So q2, since it is the final state, this. Okay, when q0 q1 q2 is inputted to 0, it moves to q1 q2 and q0 itself. So 0, and when inputted 1, it gives q1 q2. Okay, it was the initial state. So 1, when q1 q2 is inputted 0, it gives q2, and when q1 q2 is inputted 1, it gives q1 q2 itself. Yes, and we can test q2 as new state also. When q2 is inputted to 0, it gives q2 itself. When 1, it gives 5. Yes, so that means, so this is the required DFA for this Epsilon, okay, for this Epsilon NFA. Okay, and in next video we will be discussing about a regular expression and converting it into finite automata. Thank you and bye bye.